Welcome to the Glassworking Shop. Today I'm going to be testing for the very first time my new assembly fixture for putting together chip stacks of marine slices. Let's talk about chip stacking. When I first started chip stacking, I used the method that I had seen in videos and that some of my teachers had showed me, which is to put the first chip on a punty and then assemble the remaining chips using tweezers. This just didn't feel natural to me, and I never got really good results, so I decided to try doing it on a platform. First platform that I used was a piece of mild steel. Put the pieces on it, put it in the kiln, heated it up, and then attempted to stick them together with graphite tools and a hand torch. Of course, there were a number of problems. Mild steel gets kind of crusty and corroded when you heat it up, and if you get it too hot, it sticks to the glass. I tried some kiln wash, and that didn't work really well. I even got an unbelievably expensive piece of what they called high-temperature ceramic material from McMaster Carr. It cracked. Then I tried a piece of, I guess, a ceramic, what they call a kiln shelf, and it worked okay, but it was kind of dirty and dusty, and it cracked. Next test was to use a piece of stainless steel. It was a whole lot better. It didn't corrode, it didn't get all crusty, it did warp a little bit after making a number of objects. Next step was to use graphite. This is a half-inch graphite, and it's got some holes in it so that I can push up against things. And this worked pretty much the best so far. Today's invention, which I'm going to be using for the first time, is a little bit more sophisticated and engineered assembly fixture for putting marine pieces together into a chip stack. The frame is made of steel, mild steel. It's elevated so that it won't burn up my bench when I'm heating it, and also the heat won't be sucked out of the surface into the bench and kind of isolate the heat a little bit more to the chips being stacked. And hopefully the test will go well. The new assembly fixture has stainless screws threaded into graphite. Hopefully they won't get stuck when they get hot. Each of the stainless screws has a recess drilled into it that I can insert graphite rods of various different lengths. The plate that the chips sit on is also graphite. And for the first test, I'm going to be using just a socket on the end of an extension for adjustment if any adjustment is necessary when it's hot. But in the future, I may design some kind of a clever little thumb screw kind of thing that can be operated with gloves. In order to put it in the kiln, take it out of the kiln, and prepare it for use, I've got this metal fork thing, and it comes right off like that, and the base is somewhat universal, so I can still put my older designs back on it if they turn out to be useful for the work being done. So that's today's project. Let's go out in the shop and begin some preparation. I need to make a border. Let me put this guy back on here and describe what's going on. These patterns typically have a border that goes around the outside. The border is made of hexagons, which are cut to rough shape and put into place and then fused together. The piece of hex solid material was the piece that I made in yesterday's video, and today I'm going to go out to the cold shop and cut the pieces to size and then hopefully fuse them together with great success. So here goes. I'm out and back in the cold working shop, and I'm going to cut up this piece of cobalt hex, solid cobalt hex that I made yesterday, using my new prototype 10-inch wet saw, which actually works really, really well. And let's get some water going here. Okay. The saw is designed to be more than just a simple saw. It's designed to be a precision cutting instrument, and as the design evolves, I'm hoping that it can approach the accuracy of machine shop tools. The table slides on precision linear bearings, which of course are protected against the glass dust and the other mess that usually accompanies a cold saw. Right now I've got an adjustable stop hooked up to the table. There's lots and lots of threaded holes for attachment of various other devices, and I've got lots of ideas for a variety of different precision holding devices to be able to hold glass and cut it in a very precise way. What I'm going to do now is run my punty into the tripod, which is not something I was planning, so let's get that guy shortened a little bit. And got some hex pieces. Nice cut. Let's clean up the wheel a little bit, and then it's into production. Oh yeah, that's cutting better. Got an MDF backer block to kind of act as a safe stop so that the blade doesn't hit the aluminum of the fence at the end of a cut. Is a big improvement over my old Chinese tile saw. Works very smooth, very precise. I think that may be the last thing I'm going to get. So now, I'm going to set up another tooling fixture here. In order to form a border for the marine pattern that I'm making, the chip stack that I'm making, it's necessary to have the corner pieces cut properly. So I've got this, well, actually two of them. I've got these aluminum precisely machined guide units, and they, get the water back on here. They allow me to precisely cut pieces that are appropriately shaped to make the borders. Adjust that just the tiniest bit more. Okay. To do one of these patterns, it's necessary to use two different border styles. This is the first style, and the second style also has its own. Got to get the little glass chips out so it seats properly up against the reference surface. And then this guy, I think there's still one down there. Okay, it's looking better. And then this little guide fixture makes the other piece. The second piece looks like that. Okay, so there's the pieces rough cut to size, and as you may have guessed, it's unlikely that they're going to fit perfect. So next step is over to the lap wheel, and let's adjust them and make them fit. They don't have to be perfect, but get them to fit a little bit better than they fit just off the saw. These pieces don't need to have a lot of material removed from them, so a fine grain wheel will probably be just fine. Get the pieces ready here. The lap wheel is another one of my designs. Seems to be working really, really well. It has center feed for the water, and probably put the cutting disc on a little bit crooked. These pieces first. in little bit by little bit. Before I had the assembly fixture, I would just kind of roughly align them on the surface, and in the process of pressing them together, sometimes they would get a little bit out of control. I'd lose track of which one went in which place, end up having to try to figure out what's going on with hot glass and a hand torch in my hand. I think the fixture is going to make things a lot more controllable. When I squeeze and pull these marine canes, they're pretty much squeezed and pulled by eye. So they're not totally precise, but they're actually fairly close. I think all the years of building things in wood and metal has kind of like trained my eyeball to be pretty good. Okay. I need to go into the shop and get my other graphite pieces. I'm already getting to like this fixture. Just assembling the pieces cold is so much nicer now than it was before. Ah, yes. I think I'm gonna like this. That one get a longer graphite. I made several different lengths of graphite rods to support the creation of different size pieces. Okay. as I continue my exploration of geometric marine patterns, I'm working on increasing the precision of the patterns, hopefully someday achieving near machine shop accuracy in putting these pieces together. I even have a crazy idea, and who knows if it'll work, but I had a crazy idea of putting a diamond tool on the CNC and seeing if I can CNC cut some pieces, and who knows, might work, might not, but that's what's the fun about R&D. Sometimes you don't know it's a stupid idea until you try it. Sometimes even a stupid idea that fails catastrophically will inspire a good idea. Just by thinking about what went wrong, a good idea will present itself. So, I don't know. That one almost fit, but give it another little adjustment here. I think the end is near. Okay. I don't want to use too much force on this. You know, it is glass, it is graphite, and it's not designed for a tremendous lot of force, but I don't think it needs a tremendous lot of force. I think just one thing I learned about glasswork, you don't force it. You gotta be gentle. The name of the game is finesse and delicate touch. Of course, who knows, maybe when I get better at it, I'll learn how to force it successfully and have to revise my opinion. And there we have it. Now, the next step is put it in the kiln, get it hot, and fuse it together with a hand torch. Okay. Hopefully my microphone is adjusted a little bit better so I don't get any of that awful breath sound. Looks like the kiln is just about up to temperature. Tools are ready. Got the support plate positioned in a convenient place. The Inquala isn't being used for this, and so it's out of the way. Torch is moved over to the side. Really cool thing about the Unistrut is that I can move stuff around. Yesterday, when I was using the setup for the first time, I noticed that the hand torch stand was hitting a long punty when I tried to use the Elmarver, and no problem. Just change it, move it around. it's really nice to have flexibility in a setup like this. So let's give this thing a try, see how it works. I'll be using a variety of hand torches today. I've got the big one, the Mirage hand torch, which just a great torch. I especially like the hand control. Also got my little mini torch. And I might use the little Lynx too. It's a little bit lighter weight than the Mirage when I don't need the full Mirage flame. So yeah, I might actually use that guy too. Okay. I think we are ready to get this show on the road. And first step will be kind of get the thing hot. And of course I'm doing everything slowly and carefully because there's some fairly sensitive colors in here and I don't want to boil them. Usually I start in the center of these patterns and work outward. When you heat a pattern like this, the edges of the glass tend to round off. And in order to get that, I gotta get my hose control a little bit more under control. I made a little graphite push tool, kind of got a little rounded end on it like that. And that'll help barely, gently, to push those rounded edges together and cause it to fuse without distortion. Once again, the key to making this process work is be gentle. As I've learned by painful experience, it's very, very easy to distort the pattern by being too heavy-handed. You know, a little bit more fire here. So just very gently pushing these pieces together. Got to be pretty careful on the corners there. They have the longest distance to be pushed, but I don't want to get too aggressive and try to do it all in one push, to try to preserve the geometry of the pattern. Okay. And this is an incremental process. It doesn't all get done completely in the first go-round. I do the top side, do the bottom side, back to the top side. And that's looking pretty good. Yeah, got a little aggressive there. Don't want to boil my color. Although a little bit of surface scuzz really isn't a problem, since I cold work these guys anyway before mounting them in their metal frame. Yeah, let's give it a little overall heat here. Don't want to let the cold side get too cold. So far, the fixture appears to be working really, really well, and preliminary assessment is I judge it to be a success, a great success. I've made a number of these patterns just on a surface without any sort of fixturing holding them in place, and I succeeded in getting the patterns to fuse together, but sometimes had a little problem as things were sliding around and getting out of alignment, and had to get into recovery mode. I hate being in recovery mode. I love when things go according to plan. And this method seems to be working exceptionally well. I'm getting almost no distortion in my pattern. Yeah, the little hand torch is, even though the Mirage has the small flame, the little guy is lighter weight. So I like them both. For me, with a background in welding, the hand torch feels particularly comfortable. In future videos, I'll be showing how I do striping with a hand torch and the Inquala. Okay. Notice how I closed up that opening there. The corners, you can see right there, the corner is open. The corners on these Marines are never perfectly sharp, and so they always require a little bit of squeezage. to whip them into shape. Okay, so that pretty much gets the center portion of the design under control. It's not perfect yet. It's not perfectly fused. And if I took it out and let it cool, it would certainly crack apart. There's much more heating to go and much more shaping to go, but the preliminary fusing has been completed on the top surface in the center. Now I'm going to start moving around to the edges, the pieces that were cut and adjusted on the lap wheel. The piece will eventually be cold worked into a circle, so I don't really care that I'm melting these little points. They're going to be ground off anyway. Okay, time for a little adjustment. Looks like everything has gotten just the littlest bit loose, so tighten them up a little bit. Once again, gotta be gentle. These are large screws. They're half 13 thread going into graphite. And they don't need to be tightened very hard, but they won't tolerate being tightened very hard. Graphite is not a very good structural material for screw threads. Gotta be very, very careful. I'm mostly pushing straight down, but occasionally giving it a little bit of an angle, depending on which direction I need it to move. These pieces are actually fit together reasonably precisely, so I'm not having to do a tremendous lot of adjustment. As it gets more fused together, I gotta be a little more careful about keeping the thing uniformly heated to avoid cracking. And you know what? Probably not going to use the little baby torch today. No use in wasting gas. And yes, it's a slow process. That's one thing I learned about glass working. A lot of it doesn't go fast at all. But slow and careful makes the best result. Well, I'm nearing completion here on the top surface, and the object is pretty much fused together in a preliminary way, so that next I can take it out of the fixture and finish the work on flat graphite. Just a little final inspection here before switching work surface. I don't have a tremendous lot of glass thickness, so I need to make sure that the surface is reasonably flat, so I don't have to lap away too much and end up with a really wafer-thin piece. Okay. preheat this guy so I don't shock it. Preheat the tweezers a little bit. The reason I took it out of the fixture is a couple of things. First of all, I need to turn it over, and second of all, I'll be using the flat paddle, and can't really get flat with all that clamping stuff in the way. Nice thing about doing this on graphite, it doesn't stick to the plate. When I was using stainless, I had to be fairly careful and fairly aware of, is it getting too hot? I'm going to stick to the plate. Okay. So now, let's flip it. Flip it good. Ba-na-na-na-na. Bum, bum. I typically use chips about 1/4 of an inch thick, and then after fusing, cold working, and polishing, my final size gets down to around 200 thousandths, which is a kind of a reasonable size. Makes the marine go further. Doing the sculptures like I do, really the only thing that matters is the surface. So it could theoretically be very thin, but then it's really hard to work with and real easy to break. And I think 1/4 inch is probably a good compromise between preserving the amount of glass I've pulled and making a piece that is easy to handle. And then, you know, you rinse and repeat. Very, very carefully and gently squeeze. That hole looks like a big hole, but it's mostly just an illusion because of the curved edges of the glass. As the glass is heated, it kind of rolls up on the edge, and you push it back down into place, and it flattens out with very little distortion. Of course, being a precision machinist, it's never enough. There's never enough precision. I'm always looking for more precision. If these pieces were all cold worked within thousandths before being heated, make a nicer pattern and go together faster. Even though the little torch is lighter weight and easier to hold, I kind of like the flexibility of being able to go back and forth to a big flame whenever I need one. I was thinking maybe I was going to make some kind of sling or something to relieve some of the weight of this big torch. Could conceivably make a counterbalanced arm that supported the weight of the hand torch too. Of course, that's life as an inventor, constantly coming up with new ideas. Some of them are good, some of them aren't. Really important to get this surface as uniform as possible in the hot stage. With a tiny, tiny little divot or a little crease or a little hole, it takes forever to cold work out. It ends up making the piece unacceptably thin. Another thing that's going on here, if any of my marine slices had any air bubbles in them, this pretty much closes most of them up. Although, when I look at some of my pieces under the microscope, I still see an air bubble here and there. I think this, if I remember my Italian terminology correctly, this surface is similar to a pastorelli. It's not exactly a pastorelli because traditional hot shop people don't do this kind of work, but it's a variant of a pastorelli. Maybe I'll have to invent an Italian name for it. Or maybe, given my Swedish ancestry, I'll make up a Swedish sounding name. I was surprised to learn that my Swedish ancestors actually came from the glassworking area in Sweden. and I'm not pronouncing it correctly, but it's something like glass riquette in Kalmar, home of the Orifers Glass Company. The preliminary fusing is pretty much done. And there is no doubt the new assembly fixture is a success. It's a great success. Worked better than I anticipated. It's always nice when that happens. Yeah, I think I actually like the big torch, being able to go back and forth instantly. Okay. As careful as I am, I sometimes overheat my color. But it isn't a problem. The problem only occurs on the surface, and by the time I grind away the surface, it looks great underneath. So, I'm going to need a waste gas with this guy. That turned off. Okay. So now, I haven't tried this yet, but I could possibly put it on punty and then squeeze it on the squeezer to get it flat. But large, thin pieces of hot glass don't behave well, and I kind of like having them supported. One thing I learned about this operation is don't slide the paddle back and forth. It actually does drag the glass. Doesn't feel like it when it's doing it, but it definitely does distort the pattern. Keep my paddle cool. Occasionally dip it in the water bucket. Oh, burn up my paddle. That's starting to look pretty good. concern with this method is that eventually I'll eat up the graphite surfaces and have to replace them, but who knows? Who knows how long they'll last? Maybe I'll just switch to thicker graphite, and when the surface gets ready, just sand it off and have a nice clean surface. The large paddle covers more area, but I feel like I have more control with the small paddle, so hard to really have a feeling for exactly where the surface is before the glass cools down with the large paddle. Okay, time to flip it. Flip it good. Like I said, this is an incremental process. Fuse the top, fuse the bottom, paddle it flat, rinse and repeat. The small paddle that I'm using is from Griffin. Shop makes great tools. And the large paddle I made myself. No, I don't intend to go into the paddle making business and compete with stock. But sometimes if I need one, faster just to go out in the shop and whip it out. It only took a couple hours. You gotta slide a little bit because the edge of the paddle produces kind of a visible depression, but I gotta balance it so that I don't slide too much. And this piece is nearing completion. The chance this could be the best one ever, which is what I like. Constant improvement, constant learning. Of course, I happen to pick just about the most difficult hobby imaginable in glasswork. Now there's a lot to learn. Fortunately, I have great teachers. Marcel Braun, Matt Dubois, Matt Giesler, Scott Deppy, Ty Beck. Thank you guys. Really helped a lot. Okay, that is so close. I am just about ready to call that top surface finished. I've been building stuff for almost 60 years. I started as a small child. My mother used to complain to my father, he's too young to be using power tools. But they survived. I was kind of hoping that some of the craftsman's skills that I developed in working with wood and metal would be transferable to glass, and some are, but most aren't. Glass is weird. Glass has an attitude. But I love it. Absolutely love glass. I've always loved glass. Whenever there was a glass worker working, no matter where it was, I'd always stop and watch. Put it on my list of, gonna do that someday. Oh yeah. Looking good. Okay, I'm going to give this guy one more paddling on each side. And I'm going to call it macaroni. Of course, the question is always, when do you stop? How good is good enough? Could probably stand here all day and dip with it if I tried to make it completely perfect. But hey. That is good enough for that side. Really good on that side. I definitely like the graphite surface more than the stainless, and the ceramic just sucked. It was rough, it was dusty, and it cracked. I still like the small paddle better. It gives a better feedback. I have more control over what the surface is doing, and oh yeah. I think we can call this exercise a smashing success. Yeah, Zooks. I love it when stuff works the first time. And there we have it. 1H. Off to the kiln. Thank you for watching. It's been fun.